there's a neat idea about how you can count something or estimate it if it's a really big number and you don't have time to actually sit around and count every little part of that group. And this could apply to anything. It could apply to estimating the number of people in a city. It could apply to counting the number of asteroids in the asteroid belt. There's a lot of asteroids out there, and astronomers don't have the time or resources to count them all, but they still want to know roughly how many they're talking about. The way we're going to do that is setting up a ratio. And here's what the ratio rests on. This is the basic premise, the idea. The probability of seeing an asteroid in the year 2020 is about the same as the probability of seeing the asteroid in the year 2022. In other words, the number of asteroids are not changing, and the reasons why you might see or might not see an asteroid are not changing, right? Maybe you weren't looking in the right spot, maybe the sun was in your way, who knows, right? There's reasons why we miss these things, but presumably those reasons aren't going to change very much in these 2 years. It's not like all of a sudden there's more asteroids in the asteroid belt. So this is the idea, and now we're going to apply this in a clever sort of way to how we actually count asteroids, or how astronomers would do this. So what they're going to do is they're going to say, okay, how many asteroids did we observe in 2020? Right? Well, I think that's in this problem somewhere. Okay, so in the year 2020, we saw 621 asteroids. And how many are there total? Well, I don't know. We're going to call that X. That's what we're trying to figure out. And this ratio, since the probability of seeing asteroids is not changing, that ratio is constant. So instead of X on the right side, let's talk about the number of asteroids we saw now, which was 780. Now, how many of those 780 were asteroids from before? How many of them were recognizable or familiar asteroids that we had seen in the last survey? Well, according to this, that was 15 of them. So you can see that most of the asteroids observed before were not in this new survey. That means, if you think about this like marbles, if you counted a couple of marbles and then you put them into a bag and you jiggled it all up so they're random and you pulled out some new marbles and you didn't see the one you had seen previously, like you had put red marbles into the bag and you pull them out and there's nothing but blues, you would assume this must be a really big bag of marbles because your red ones just got totally lost in there. Something like that going on here. You can see that the odds of seeing the old asteroids again in the new survey seem to be very low, right? Only 15 chances in 780. That means there's a lot of asteroids out there. So let's solve this equation of ratios, and we're going to get an estimate of roughly how many asteroids are in the belt. Okay, so the way you can do this is like any ratio. You can multiply each side by x. Okay, that's going to cross out these x's. And I'm also going to multiply each side by 780. And that'll cross out these 780s. So this is not bad. I get 780 times, 780 times 621. Whew, that's a lot. 484,380 equals 15x. Great. We're going to divide each side by 15. And that'll give us an estimate for x, the number of asteroids in the belt. 32,292. Okay, so kind of in the right ballpark. Scientists aren't quite sure exactly how many there are, but it's somewhere in the 25 to 40,000 range. And there you go. That's a kind of neat application of ratios.